Si no hay que conectarle a YouTube, estaría tremendo.
Coño, sí, ¿no? Ahí.
Es literalmente darle story ya. No, no parece que está sirviendo.
Que estás,
No aparece que está sirviendo ahí, el canal. No
¿Estás
aparece.
ahí?
Sí.
Coño, quedaron todos esos videos ahí.
Sí, va a haber que borrarlo. Videos de prueba.
Sí. Genial hubiese sido. No, mira, al vivo.
Ah, no. Wow.
Wow,
Mi teléfono está.
solo tienes que. Ok.
Mira, sí, es verdad.
Sí, sí, sí. Ok, ya.
Wow. Es que sencillo.
Tenemos que cambiar a inglés ahora.
Yes.
Sí, yes. True. Okay, so I'm gonna point it to Jupiter, and we're gonna focus the camera. Okay. And in 4 minutes, I'll start the stream. You know what the problem is of not having YouTube on? That you can't see if there's anybody on the chat or anything.
Oh, that is true. So YouTube is a necessity.
Yeah. Let me see. YouTube. Esto no es video. These are us, I'm guessing. 2 playbacks are probably us.
Especially since no one else is watching. Right?
Yeah. Okay. So here's a shot. Okay, so shot streaming. There's one problem in which is where are we going to display the pictures? So let's go let's go to Saturn because it's cooler because we can't see it on the plane.
I mean,
so it's low or there's absolutely nobody here. So the thing, so they're gonna be seeing what is it that we want them to see. So we want them to see this or the picture, or this was my idea. My idea was something like precisely having so having something like this, and then streaming this, so something like this.
I see.
Right.
Yeah, I mean, you do have the option to like show either screen, so I guess it's an issue with watching the like people in the chat and putting this on. I wonder if we can turn off the other computer and have the chat and this other stuff.
Like have the shot over there.
Yeah.
Somebody else doing the shot.
Yeah, and then like the screen for like pictures, the screen for the like sky map,
and then being like this.
and then just like putting either one of those and like exactly.
Well, you know what the problem is? That the problem is that if we make this the monitor,
Right.
we get this.
Because you have this part here.
Yeah, like you can't stream this. The monitor where it has the streaming.
Yes. But do you need to? Oh yeah, you do actually need that.
Do we?
I mean, just in the sense of like changing it from like if you're watching left or right.
Yes.
It's the only reason why you would need that.
Exactly, but if you.
But yeah, you can minimize it.
If we minimize it, and we do this, the thing is now we don't know what the output is.
Yeah.
Right here.
So what I was saying by minimizing is you can like basically It's all the way down there.
I
so
lost it.
So maybe try right clicking. Pin. Where are you though?
Oh no, that's not it. Maybe it went over here.
No.
Damn, I really.
Wow. Well, it is 8 now, so you can start streaming again, I guess.
Close it?
Yeah.
Wait, yes.
There should be an option to like.
To bring it up. Yeah.
Right.
Follow this. Well, that's just spinning this. Close window.
Yeah. Well.
Yeah. Alright, we're back again.
So what I was thinking is like you can like close exactly and just have like this little. It's very small, so.
Yeah, I see what you mean.
Yeah. I mean, it's not perfect solution, but.
And I'm thinking that I find this useful. I want them to know what's being displayed.
I see it. No, I see.
Yeah. You know another thing that we can't display that I've seen a lot, which is the chat. Like I see the chat like kind of like overlaying over the streams.
Okay, I see. Yeah, that would be nice. Media source? No, I
I don't think so. Text. Browser.
Maybe.
Okay, so if we have this over here,
Right.
and we have YouTube. Okay, now there's more playbacks. This is not us.
No, that is not us.
Yeah. Anyway, I think that let's do that for now, and then let's just overlay the picture here, and then let's see how that works. And if it doesn't work, then we go and we use the other.
Yeah.
All right. For the 2 people viewing this stream, hello and welcome.
3 of them now.
3 of 5, no 3. So we are focusing the CCD camera, and we're going to show you guys the images of whatever you want to see, and then you guys can write on the shot.
Actually, I think you're showing right now. I wonder if it's delayed or.
What am I showing? Oh, I'm showing the wrong monitor.
Yes. Now you're showing the right one.
Okay, there you go. Alright. So go in. Jupiter may be too big for focusing, but let's see.
Is it a. What's this? This control is where you manage the focus as well, right?
Yeah, that's where you manage the.
So.
Is it? No, wait. Are you getting the? I think you're getting the wrong one.
I don't.
Yeah, you're getting the wrong one.
Right. So.
Okay, so that one is to slew,
Okay. Yes. Exactly.
and these are the different speeds.
Exactly.
And it also has a little flashlight. And then this one is
The one.
the one we moved.
Okay. Perfect.
So you didn't move it.
No, I used the the slow one, so if it moved with you.
Okay.
So slow.
I mean, it's still centered. So
Yeah, exactly. So. I'm just going right now. Nothing at all.
Keep going. So you know where when is focus. So this is a way to focus the camera, and what we mean with focusing the camera is the image comes through the telescope, and it forms at a particular distance from the secondary mirror. And that distance has to be such that the image forms and it resolves, right? Now, the way it's very hard just by looking at. You're going the wrong way. Go the other way.
Yeah. That's what I'm looking at the picture right now.
Yeah. It's very hard by looking at a picture to know if it's perfectly focused because there's so much distortion of the image due to the seeing of the atmosphere. So this is a way where we use the refraction of light. Now go the other way. We use the refraction of light to focus the camera, and what we're trying to do is that you see it looks like a star, like it has 6 rays, and we're trying to put this middle ray in the middle of these other 2 rays. And when that happens, now you're going the other way.
Okay.
Go the other way. So here you see basically these 2 triangles have to be similar, or they have to end at the same depth here. A little bit more. Yeah, I think that's good.
Okay. Yeah, because I can't really see that well from here. So.
I think that's
Okay.
maybe no. What, a little bit more.
Okay.
There.
Okay.
Okay. Now we're okay. Now we're gonna remove the. So we have basically a mask, something like this. Which is creating the refraction, and these slits are particular angles that will make the light form the pattern that you see on the image. So now we're gonna take it off, and you should be able to see Saturn just fine. I mean Jupiter. Let's see. It's saturating. So let me change the exposure time. So let's have 0. Still saturating. Kind of weird, but it is still saturated. Yeah. What are we looking at? We're looking at
Sun.
Yeah. Well, let's have. I don't think we can do less than 0.001. Take 4. Where is the photo?
Maybe it's hidden.
Let me see. Hello?
Okay, there.
There it is. Okay. Yeah, it's super saturated. So what we can do now, if it's saturated and we're having the minimum exposure, we can use a filter. And we already have a filter. So let's choose green. Actually, let's use something that we know that there's not going to be much of. This is like blue. Let's take a picture again. Okay, that's better. Yeah, so now it's not saturated at all, and in order to see like the details, like the rings, we have to change the contrast of the image. There you go. So that's Saturn. It's not that bad, given all the like light that we have. There's still a lot of light.
Yeah. Still twilight.
And we can do better. So we can do a better image if we use an oil filter, and we are close to the cap, but don't saturate the camera. It's a pretty good picture. What do you want to do now?
I guess we can ask them if they specifically want to use something. I guess.
Yeah. Or is there anything you want to point out?
You can just write it in the chat.
But I think that it will be better in general to have something prepared, right? Like the people doing this should say like, okay, we're gonna talk about Saturn, and then we're gonna say this and this about Saturn.
Yeah, I see.
And then have them come in and be like, ask questions, and
I see.
you know.
Yeah, I think specifically like at the beginning, it is probably much better
To start it like that.
Yeah, because people will be a little bit more engaged.
Exactly.
Nice.
So that's what I'm gonna do. Actually, Saturn is my. It's my favorite planet. It's what I do. People say that it's named because it's always Saturn, but I mean, look at it.
Yeah, it's amazing.
It's pretty cool. So something that you can barely see in this image, and we're gonna let me tell you to take another one, because I have taken pictures where you can see the difference in the brightness of the rings. So some rings are there are many rings first and foremost, because you can see a difference, a marked difference in the composition of, or it's mostly the reflectance of the rings of Saturn as you go out in the radial direction. And we have identified how many? See, 7 rings so far. From inner to Saturn to the outer Saturn is like the D ring. The D ring is basically the material that is on the gap between Saturn and what you see, the solid ring that you can see on this image. Then there's the C ring, which is the innermost ring. And the C ring has a lot of interesting features because there's a lot of interaction between the planet and its atmosphere and its gravitational pull that happens because the planet is not spherical, and the rings. So you have the C ring, then you have the B ring, which is the darkest one. Then you have the A ring, which is the most dynamic one. There's a lot of waves on the A ring, and it's also, so that means that it has to be very new, because the waves actually open gaps, and the time frame at which the gaps open in the rings is actually millions of years. So if there is a ring there and not a gap, then the ring has to have relatively created relatively recently, the A ring specifically. Then there's the F ring. The F ring is an interesting thing. We're not going to be able to see it here, but there's actually a gap between the A ring and the F ring. So the F ring is just like a little ringlet that is very nicely is the final like eyeliner of the rings of Saturn, and it's also very reflective. So it looks very nice on the pictures. And then there's a mess after that, because Enceladus, which is a moon, is creating a lot of material that is rotating around and creating a ring, and that's the E ring. So those are all the rings, and I'm gonna try to at least so the B ring is dark and the A ring is very bright. So you should at least be able to see that difference if I manage to get a good picture of Saturn. So let me play with the camera a little bit. So let's do blue. Well, we're kind of doing super blue. This is the violet, green,
I think
red.
Red is.
Like ultraviolet. I mean, we're doing HF. I'm guessing that we don't have the filters, the bands here. Here, look. Well, the viewers can see it, but we have here exactly what wavelengths are which filters. But there's no H alpha here, but H alpha is around here, right? So I think there's an overlap between U and H alpha.
Oh, I see.
Where am I? What was I doing? Yeah. Let's see how it looks with red. Perfect. And let's take picture. Yeah, obviously super saturated. Yeah, saturated. Infrared. So what we want, this is saturated, so the pixels are getting their maximum value, and then that means that all the pixels that are seeing too much of a bright source are all having the same amount of whiteness. So you're not going to be able to see any contrast between them.
Also, you want to point out some of the new structures that we're seeing here as well because of the all that saturation like outside.
Oh, like you mean this?
Yeah.
Oh, you're right. Do you want to talk about that?
I don't know a lot about it, but I think those are the moons, right?
Yes. Let's see. No. Here, this
Last
is
one,
a good
yeah.
one. Yeah. So we have 4 moons. Well, this is yeah. I don't know if this one is a moon.
Yeah. It's kind of far away.
I mean, yeah. Could be. Wait, which one is a good one? This one. Yeah. But these are definitely moons. All of these 4. But which moons, it's tricky to know. But the big ones are, the biggest one is Titan. Right?
At least we know.
So if this is a moon, it's Titan, for sure. And also Titan is further away than
The rest of it.
Enceladus and Demeter. Well, Demeter is inside of the rings. Mimas, Janus, all of these are inside.
Right.
But I don't know which moons are these ones.
I think you can also check on the map thing to see the sky map.
You're right.
To see if
Let's see if it knows. That will be.
Yeah. Because last time we did it, see.
Yeah. So
the
look.
Position.
Yeah.
Oh, it is Titan. Probably.
So this one, the one out there was Titan. And then you have Mimas, Enceladus, Dione, Rhea, and Tethys. You can see a lot of them.
Oh.
I haven't been able to see that much in one take. And could you be able to see this too? Let's see.
Let's see.
I think that's the only way to put the picture back in.
Oh.
Maybe this one. No, because these 2 are according to that. Let me see. Sorry. Yeah,
No.
I really doubt. If anything, we will see the star before we see any of this.
Mm-hmm.
Okay, that's pretty cool. We can check. What do you know about them? Do you know anything about the moons?
I study the sun.
Guys, oh well. I mean, we can look at the sun right now.
Exactly.
Yeah. What are all the astrophysics people are gonna do? Well, I guess if you're stellar people, like you can look at the nebula or something and talk all about star formation or whatever it is that they do, and like
Yeah.
spectra and play with filters and whatever.
Yeah, I would imagine yes, and also like maybe like preparing, as you said, like preparing a little bit of a script just to like know what to look at.
Yeah.
You don't have to be an expert, but if I think you're a little bit more prepared about like specific things that you want to look at.
Yeah, like for example, if we actually prepare this, we would have read something about the moons. Yeah. I know, and Enceladus, I mean, Titan, Enceladus, and Mimas, there's a lot of things to say.
Doesn't Titan have like a methane cycle?
Yeah.
That's interesting.
So we sent a probe to Titan.
Yes,
right?
yes.
Yeah, we have all of these images of the surface, and the images show mountain valleys with rivers or lakes, and those lakes aren't water, but they're liquid methane, which the methane cannot exist as liquid in the surface of the Earth, but it does in Titan.
The pressure's still big.
Yeah.
Wow.
And that's pretty cool. I think we're planning a mission to Titan. No, we're planning a Europa Clipper. But probably this decade, in this decadal survey, we're gonna see missions to Titan.
Nice.
So that's Titan. Let's put some images here actually.
Yeah, and also but like for the rings, we were explaining. Nice. Oh, look at that.
So Saturn was a Titan. Is that what it's called, Titan?
Yeah.
Oh, this is of course an artist thing. Although this picture looks like an actual like picture of the Earth, and then they put
Yeah, exactly.
Yeah. Okay, but let's see if I find the actual images. This is also.
Artist. Yeah.
Sorry. So I think it was Huygens. There you go. So Huygens was the name of the probe.
Wow.
And I think this is a sequence of actual pictures that it took.
Yeah.
Yeah.
It's on the NASA site, so.
Yeah, it is.
Wow.
So this is when we actually know geology and talk about whatever this thing is. I'm sure, but the good thing is that somebody that does geology is going to come here and it's going to talk about Saturn because it's going to be out the entire semester.
Yeah.
And then they can have their
Full discussion on.
discussion on all the geology of this structure that we're seeing in this probe.
I guess it would be nice just for like for us bookkeeping, like as people sign up, like for them to like choose a
Like
topic.
advertise them.
Yeah. Advertise and then like actually like make them choose a topic beforehand, because that way like we can advertise it.
Oh,
as
you're right.
well.
You're right.
Like hey,
That's-
today
so
we're
like
going, this Friday we're gonna talk about like geology.
so they sign up, and then we ask them, hey, like you have to have something kind of prepared.
Yeah.
Yeah, actually. So yeah, these are real pictures taken by Huygens. So Huygens was a probe that was attached to Cassini, and Cassini dropped Huygens on Titan and then kept doing its study for a long time, 10 years. And this is it. This is the last picture. Like it stood there, and it's the last picture it took. And then it ran out of battery, eventually. Yeah. So that's pretty. Oh, look at this. So yeah, this is. These are much more. So that's Titan, which is over here. Wait, we had a picture. It's better to show the picture. Where's the picture? This one over here, Titan. Now Titan, as far as I know, it isn't really promising life-wise. Speaking of astrobiology.
Yeah.
But there's one there is, which is Enceladus.
Oh.
So Enceladus, which we know, wait, let's go and see. It's this, wait, again. This one up here wouldn't correspond to anything.
Yeah.
Maybe this is wrong.
Maybe that.
But it's like a little bit old.
Yeah. I don't know. Maybe like that one spot that's like all the way up there.
This one.
Right.
You
like
think it's
green.
this?
Maybe. I'm not sure. I'm thinking about the distance for Titan and
like this is probably Tethys. This one is Tethys. Like
yes.
Mimas is much smaller. It wouldn't come out like that. And then you have like two distances to Tethys. Maybe people might be talking. Did I close the browser? I closed the browser. YouTube. Yeah.
So one thing that I was wondering is like, what, like you mentioned one of the other like moons might be a promising candidate for like life. So what would be the difference between that and Titan?
So because Enceladus is closer, so we see Enceladus is closer. I mean, a problem with Titan is that even if it has an atmosphere, it's still, if you can have liquid methane, you cannot have liquid water.
Yeah.
Which is the ingredient that you need, right? Main ingredient. And the reason that Titan can, it's too cold in order to have it. Now, to have water. Why is Enceladus is basically at the same distance from the sun? The reason Enceladus is warmer and it has a inner sea of water is because there's tidal friction between. So basically, Saturn. Saturn will make things go around itself. Of course, all the moons go around, but it will also stretch you, because the part of you that is closer to Saturn is more strongly attracted than the part that is far away. And that stretching creates a lot of friction in the inner part of Saturn in the inner part of Enceladus, that creates the heat that melts the ice and makes it so that there is a global sea of ice in there. Now, how do they discover the global sea of ice? I mean, you see a lot of plumes, so you see a lot of water vapor coming out of Enceladus on the pictures that we take from Cassini. But we know it is a global sea because we know so the dynamics of a solid thing is different from the dynamics of a thing that has a shell that is separated from the core by an ocean. You can think about the fact that the core may wobble and the shell might not follow, but there may be a lag because there's fluid. And that wobbling, we know the position in the where the core is and where the center of mass of Enceladus should be. So basically the core, and we can see how it looks. So we can see where it is and how it looks from Cassini, and we can compare and see that there's some discrepancy in its position, and then we can conclude that this thing is behaving. Also, then we include in the simulation the ocean of water, and we get the actual trajectory, and then we see, okay, this is behaving like it has a global ocean separating the mantle from the mantle is the outer, right?
Yes.
The mantle from the core.
Yeah, exactly.
Yeah.
Crust.
Yeah. That.
One of them. Depends on.
I took like earth sciences in high school.
And I guess like the little I know is because my brother's a geologist. So.
There's the only thing I remember is like erosion. That's all. Erosion, the metamorphic rocks, and igneous rocks. That's probably all I need to know. I'm kidding. All right, and then all of these other moons are also very interesting, and I don't know anything about them. Sorry. Let's see what we find. Okay, I think we should have 2 Googles. We should keep the YouTube here,
Yes.
and then I'm gonna send them YouTube people to see if they participate. Saturn. No. These emojis are pretty bad. Is this like Twitch when you can give them emojis?
I see.
I don't think so.
I think these are like the regular.
The regular ones, yeah. The WhatsApp. Okay. Where were we? Sorry, we were looking at Thea. For Thea the planet. What the heck is the other planet? Thea is an American ship. No, what's the other planet?
Yeah.
Oh, that's like on the. Oh. Is that the one that is
Oh,
close?
yeah.
That's the one they hit.
The collision, yeah.
Well, it's Thea. It's different than.
On
Oh, what? Yeah, actually, it's not even that, it's Tethys. I'm confusing Rhea and Tethys. Or is it Tethys?
Yeah.
Tethys planet, apparently. Yeah, okay. There's not a planet. There's a moon. I didn't know. I knew about the okay, Seth. I knew about the theory of moon formation, but I didn't know the name of the body.
Yes. It's new.
But yeah, or maybe or wait, is the theory that it still exists? Because then maybe I did discover it. Let me see. Is an Asian planet? No. Yeah, if I damn maybe it isn't. Who knows? Maybe it survived. Or you know how light works. It's so far away that we can see into the past, and we can.
Seeing the cosmic microwave.
Okay, so that isn't super interesting. So the as a dynamicist, the only well look. So there may have been some volcanic activity due to the style friction that I was talking about, but right now it doesn't really look like there's any. Is there resonances? The cool thing about these seemingly very boring moons is that they affect the rings, and then they create very cool things in the rings. So let's look at the rings. Now we're in the rings. Look, there's a band named Rings of Saturn.
Yeah, I was looking at that.
So original. Deathcore.
Oh wow.
Look, in 2009, I think I was like the end of the Cassini first like non-extended mission.
Really inspired them.
So look here we this is a picture taken by Cassini, and here we see this little ringlet is the eyeliner, like the F ring, and then this cloud of material, which here is very hard to see. We're seeing that it's deflecting the light. First, this picture is obviously altered to have a very good contrast and see it. But this amount of material is very faint, and it happens at the orbit of Enceladus. So I told you that Enceladus was releasing plumes from its surface, and as it goes around, it creates this toroid-like ring. Okay, let's see everything outer rings. There's okay. I don't know what I thought that you were gonna have. Okay, ring structures. Let's see. There's some gaps. So there's a picture of the rings, and as you see, you have a lot of structure.
Seth is asking if we imaged Saturn, and we did a while ago.
Yeah. Here. Wait.
Now it's really saturated.
Well, did we saturate it? There you go. Wait. Yeah, it's saturated. So we were trying to look at the moons, but we use a filter set because we already have the minimum exposure. So if we use like H alpha. Now we're talking about the rings. I should
go back to Saturn.
Yeah. Maybe what I do, remember, I wanted to. Oh no, this is too much. Do this. Where did it go? There you go. It's okay. Emacs. But you still can't see much of the structure here. I mean, I can see it. But there's a lot of structure in the rings, and the structure is created by the moons. So even a very boring moon like Tethys can create cool stuff like gaps and things on the ring, and that's what I want to see, if Tethys has any interesting resonance. I don't see anything cool. Maybe Tethys is kind of boring. Also, they're not really talking about what creates these things. For example, the Cassini division is created by a Janus resonance. Well, here talking about the 523 Mimes, which creates, yeah. So I told you that the A ring is very dynamical and has a lot of structure because it has a lot of resonances with a lot of the moons. And here they are talking about that. So Mimes has a resonance, the 523, that creates a very big wave, and creates also a very tall vertical structure that is a kilometer high. But I don't see Tethys doing anything. Final call for Tethys. No. For Tethys. Aha, E-ring. Okay, that's something interesting that we should see about. So some of the material of Enceladus is falling on Tethys. That's interesting. Of course, we're not going to be able to see that on this picture. There you can still see Titan here. Let me take a longer exposure. with this filter. Is Seth talking? I feel like I should. Ring shadows. Ah. Yes. That's a good point. Does that make sense? So you can see the shadows of the planet on the rings. You mean that, Seth? Here. So if the sun is coming from this side, then you should be able to see some of the ring obscured by a planet, and that's something you can see on this picture.
Yes.
Perfect. But now I want to I can make it brighter, so I want to see. Let's make it brighter. Let's saturate with this filter.
So you're saturating it because you want to bring out the moons, yeah? Or
The moons and also the bigger the collection, the bigger the contrast.
okay, I see.
Yeah. Wait. It might not be easy. Oh, that's too much.
Okay.
Yeah, but now this is too little.
So maybe like
4?
maybe. You were at 3, right?
I was a 1.
Oh, you were on 1. Oh, I thought you were on 3. No.
No, this is great. This is good. But of course, now that contrast doesn't work out. But it looks brighter, and you can see. You still can't see any features, and it's still very uniform. Even if, well, here, this is probably not the A ring, but just the ring fading away. And here you see this a little bit more obscure. But otherwise, if you see this number here, that will give you the pixel value, and the maximum pixel value where it saturates is 65K, 65 something. So this is very close to saturation here in the middle. But you can also use this to see differences in contrast that you could not see by eye. And I really can't see much of the structure. Now, another thing that will really mess up with the resolution, so be able to distinguish one object that is very close to another object, is of course the atmosphere, the seeing. So the atmosphere, the light has to go through the atmosphere, and the atmosphere moves, and as it goes through it, it will make the image more diffused and less defined. But if I keep taking pictures, eventually I may be lucky and be able to see at least a little bit of contrast between the A ring and the B ring, which is what I want to get. That contrast is precisely this, right? This idea. So this is the B ring and this is the A ring. And I told you the A ring was darker, but if you reverse the image, you will get the opposite effect, of course.
Hello?
So Sommers Bausch Observatory.
Yeah, Sommers Observatory? Yes, hello. Can you hear me? Yes, hello. It's myself. It's been going okay. We're right now looking at Saturn's rings. Mostly, yes. Yeah, it's mostly I guess like we've been like talking at the screen, so Seth's been responding through the chat, so whatever he sends like.
He's gone now.
Okay, so yeah, then I'll just
See you, Seth. See you next week. Tune in for more astro fun.
Okay. Yeah, that sounds great.
Who is it, Fabio?
Yes, it is fun.
Just tell him to
Okay.
see the stream. What did he say?
He said he's going to like watch the stream now.
Okay.
Like I think he's watching, but he's not like chatting a lot.
Okay.
So
Okay.
He's saying like he's gonna.
Well, I know we have 4. We have 4 viewers currently.
Hey, 1 like.
We have 1 like. Wait.
Seth.
That's probably Seth. Like there was a point, but it's not 4, including us at the beginning.
Right.
Like there was this magical moment. Okay, guys, I'm gonna show you this. The statistics of the stream. We have 4 at some magical minute. Oh, and also here, there's people like going. I don't know. Well, now we have 4.
Oh, look at that.
Yeah, and this is
plateaued at 4.
It is. I think like this is Seth leaving. So
Yeah, maybe.
we are a success.
Yes.
This haven't been advertised, right? This because this was a test. But the idea is to have it advertised.
Yes.
So Seth told me that he could use the. Well, John, why don't you tell your friends that we're doing this? Okay, it wasn't advertised, like nobody knew, right? I just sent an email like 2-3 hours ago.
Yeah.
But Seth told me that he can use the, like he used this wording, the, no, it wasn't publicity machinery or something.
Yeah.
Propaganda machinery of Fisk, and it's like, I don't think it's I mean, maybe it is super powerful propaganda machinery, but. Seth is still in, so this is not Seth leaving. This is not Seth leaving. So anyway, John, we will advertise it. Hopefully, when people know about this, they will come.
Yeah, and also like if we get the grad student community involved, we might be able to like convince them to like share the information as well.
Like on their social media.
Yeah.
Yeah, because we are influencers, right? All of us are influencers.
Yes.
See you, Seth.
Bye.
So if we post this on Twitter, then we're gonna have. Yeah, but I mean, I guess this is a good thing about this is that now anybody can watch.
Exactly. So
You don't have to be in the Boulder area.
Exactly. So like I'm thinking like I have a few friends that are really into this like back home that they probably would love this because like there's not a lot of like observing options. So
yeah, that's a good point. So if we all share on Twitter, so first we have to have like the Fisk stuff because Fisk has social media.
Right.
So we have to have the Fisk stuff coming out, and then people can retweet. And then we're gonna have like millions of people here. This will be the most watched stream.
The best thing on YouTube right now.
And then we can make it so that they can use the chat to control the telescope. No, that would be a disaster.
Wow.
Like Twitch plays SBO.
Now watch Jupiter. Now watch Saturn. Now watch Jupiter.
Well, there's no Jupiter today.
No.
Or do you want to watch Jupiter?
No.
We're all okay. Jupiter is not at school.
That sounds like a disaster.
So instead of this, Mimas has a bunch of Rhea. Let's read about Rhea. I don't know what's going on with these moons. It probably also has some. So what do we look? We learn from Tethys that is receiving some of the material from Enceladus, and you can see it on the pictures, just not on this telescope. Rhea, sorry, Rhea Saturn. I know Rhea has interesting resonances because I've seen them. And apparently it has rings. I didn't know this.
It has rings?
Well, like,
oh, look at that.
I don't know. Does it have rings? Has some craters.
It does have a lot more.
That sounds like a fast.
Surface.
I don't see any like. I mean, if Rhea has rings and Enceladus has, like, what will be the rings of Rhea? Will be, the thing is that anything that is the rings of Rhea is just the rings of Saturn. So it will follow, unless you're very close.
Right.
It will follow the orbit of the rings of Saturn instead of around Rhea, because of the heel sphere. Oh, look! Speaking of heel sphere, possible ring system. Okay, let's see. Ring system was in favor of exploration in the fall of Saturn. That's a little bit of far-fetched. So the heel sphere. So this is actually a very good example to talk about heel sphere. If you are a dust particle that is close to Rhea, are you going to orbit around Rhea, or are you going to orbit around Saturn that is much bigger? And the answer to that is this idea of the heel sphere. The heel sphere is a sphere that of the gravitational force of Rhea that is around Rhea. That if you are inside of the sphere, you will orbit around Rhea, and if you are outside, you will orbit around Saturn. And it seems like there could be, like, at least dynamically speaking, it is possible that there is some debris that's rotating around Rhea and not around Saturn. But they didn't see it. Interesting. Suggesting that another explanation of the early observations is needed. So, what's going on? Here's a paper opportunity. I didn't know about this. Maybe I should talk to Larry about this.
There you go.
So it's dynamically possible. Oh. Well, John, because you are a solar physicist, then you just think about the heliosphere. Exactly.
Don't be honest.
By the way, Marcel here. I don't know if you're on the shot, Marcel.
No, it's the camera's like over here. I can try to.
You should put yourself on the shot for sure.
All the way over here. It's not like it's gonna help me a lot.
No. Like, well, I mean, they can barely see me. I was thinking about like that.
Yeah, I am trying to like. Okay, so I think now they can probably.
All right, so Marcel here on my right. So is a solar physicist too, John. So I guess I'm outnumbered. So this is pretty interesting. What do you think is happening? So there's a flux of electrons. Do you think there is something that is receiving this flux of electrons? Now that I think, there are dozens of you, but you are still a minority on the department. Still, you haven't conquered the department completely.
Come on, go to NSO and say that again.
No. This is so curious. Like, what? Look, it says the case of the ring was determined by so you can find in solar presence of set of small ultraviolet bright spots distributed along Rhea's equator. But I guess, like, damn. There's one explanation to all of these weird things. So you have all the evidence that there's this thing, and then when you go in and take a picture, it doesn't exist. The way you think is happening. Aliens.
Of course.
Yes.
The only
Aliens probably have some type of base around Rhea.
Yeah, they're jamming. They jam Cassini's.
And they're jamming Cassini. Yeah, we're getting other signals, but when you get the pictures, they have some stealth device. 100%.
Yes. That's
Okay, I should publish that paper.
That's why now we need to send another mission.
Well, there should be a paper of like how aliens explain everything. Everything in astronomy explained by aliens. All right, I think we're done with the moons. But I think like 1 hour is enough. Like start at 8, end at 9, or I mean I think start at 9. Honestly, if you do anything else, we're still a little bit in dusk.
Yeah.
So start at 9 and end at 10, and do I mean Saturn is a particularly thing that I can talk a lot about, but do 1 or 2 bodies, I think.
Yeah.
And then if the public wants to see other things, except transits, those are space vampires.
Yes.
What?
No,
What do you mean, John?
I can't see what he said.
He said, well, that transits are not explained by aliens, but by space vampires.
Ah, yes. Space vampires.
Like they are blocking the light, but they don't want to block the light themselves, right? Like if there were a vampire on Earth, why would they create a transit? I don't understand this space vampire theory.
There's no paper.
There's an archive paper about the transit of space vampires. Oh, so like if a space vampire. But the thing is that the space vampire will evaporate because it's being hit by the starlight.
Oh, yes.
Right? Or are these space vampires like the ones on Twilight that are kind of lame?
Sparkle. Weren't the original like vampires like not affected as much by light?
Yeah, that's a good point. I'm not entirely sure.
Maybe that's why we're misinformed about vampires now.
Maybe vampires don't evaporate. So it's not like Blade. Okay, we have 2 viewers. So no, we have 3. What the heck? Oh yeah, we have 5 at some point.
Wow. Someone keeps coming in and out.
Yeah.
That's interesting.
I think that people somehow like
Find
like YouTube recommendations are crazy.
And then they watch it and like, what's going on?
So is there anything you guys want to see? We don't have pictures of space vampires.
Sorry. We tried.
We did almost all the moons. But actually, let's before we leave, let's look for Enceladus. Talk a lot about it. Potentially, it has life. I will bet that it has life.
Look at how pretty those pictures are.
This is a picture, but is this a picture? Because this is very ridiculous how they got the plumes.
Wow. Yeah.
I don't know, but this, I mean, you can see plumes, on the poles. Like, this is a good diagram showing what we were seeing. Potential for life in aliens, apparently. Look.
Oh, see, that's where they are. That's where they can.
I told you guys. Everything is explained by aliens. Oh, there's a lot of propaganda for Enceladus. Like, Europa is no longer cool. So Europa is another moon like Enceladus that we are gonna know about all of next time, where we're gonna do Jupiter. But nobody cares about Europa anymore, apparently, because there's a new one.
Yes.
Yeah,
There's a new moon in town.
a new moon with water, with space whales. Best bet for life beyond Earth. Well, guys, that was it for today. See you around. We're gonna be here next week. There's gonna be other people that we don't know who it's gonna be, but it's gonna be other people with other expertise looking at Jupiter. I don't know any Jupiter people.
I think, I don't know if there's someone in my year that I think is interested in Jupiter. I'm not super sure.
Is this the girl that does plasmas?
No.
Maybe she wants to work on Juno.
No.
You know what they say today? Look, speaking of rings, I have Astro News. So they're planning the extended mission for Juno,
Is it?
and they said that one of the priorities is going to be studying the rings of Jupiter. So that's great for us dynamicists that does rings.
Wow.
All right, guys. Thanks for coming, and see you next week.